Assalamualaikum warahmatullahi wabarakatuh. I'm Halim Dwi Putra and I'm one of the member from Group 1. And my other friend is Syahidan and Zelynda. Right now we will present about our project in manufacturing planning. First of all, we need to determine the materials demand that we need for our project. And that one will be explained by Zelynda. To Zelynda, please welcome.
Material demand minimum dimension for each piece of product. So there are three components with a different size for each length, weight, and height. For the first component, it has a length of 18 mm, weight 18 mm, and height 30 mm. For the second component, it has a length of 20 mm, weight 20 mm, and height 36 mm. For the third component, it has a length of 15 mm, weight 15 mm, and height 18 mm. For the minimum dimension, we should reduce weight as much as we can because our group decided to take box form for the material, so we can just buy a bar of box then separate by 3 because its minimum dimension there still needs to offset. So here is the calculation. So the material we use is duralumin. We can suggest the size of duralumin bar for a product after we know the result of the formula. Length, weight, and height has a different formula. The offset we can use 2 mm for each. The length formula is total length plus total offset. 115 mm plus 6 mm equal 121 mm. Weight formula is maximal weight plus offset. 80 mm plus 2 mm equal 82 mm. Height formula is maximal height plus offset. 36 mm plus 2 mm equal 38 mm. So for the minimum dimension, the duralumin bar should have 121 mm times 82 mm times 38 mm equal 377,036 cubic millimeter.
And the next one for machining process that we already made will be explained by Syahidan. Syahidan will explain part 1 and part 2.
Okay, now we're talking about machine processing. We got the first part. In the first part we use the milling machines, and here we got the first step is face mill with a 15 mm face tools, and then with the 6-minute setup time and 169 second for the run time. After that we got 2D pocket with the tools of 5 mm flat, and setup time is 6 minutes. Run time is 435 seconds. And after that we got drilling process with the tools is 10 mm diameter of drill and 8 minute setup times, and then after that we got 31 seconds of run time. After drill we got 3D contour with tools of 5 mm flat and mill, where the setup time is 8 minutes and the run time is 435 seconds. Now we continue to the second part. In the second part we use two machining process. We use turning and milling. First we're going to use turning with a face with a tools CNMT right hand corner radius of 0.8 millimeters, and the setup time is 2 minutes and the runtime is just 26 seconds. After that we got profile with a VMT right hand corner radius 0.2 millimeters. Tools, and the setup time is 5 minutes with the runtime is 109 seconds. After that we got finishing with the tools is VMT right hand corner radius 0.2 millimeters, where the setup time is 2 minutes and the runtime is 83 seconds. After that we use the machine of 2D milling that we use is circular, and the tools is flat mill 4 millimeter diameter, and the setup time is 5 minutes with the runtime is 77 seconds. And the last one we got part that cut off with the machine turning machine. This step we're using the tool of turning grooving with a corner radius 0.8 millimeters and 10 millimeters diameter, with setup time is 3 minutes and the runtime is 55 seconds.
Because we have 3 parts for machining process, and part 1, part 2 already explained by Syahidan. Next, part 3 will be explained by Zelynda. Zelynda, please welcome.
For the component 3, it has a 4 operation or 4 step. For the first step, it has a phase in the machine turning. Tools or cutting tools that we use is CNMT, right hand corner radius 0.8 millimeter. Setup time is 3 minutes, runtime 29 seconds. For the operation 2 or second operation, it has a profile which has a machine turning. Tools VNMT right hand corner radius 0.2 millimeter. Setup time 5 minutes and the runtime 46 seconds. For operation number 3 or third step is finishing. Machine is turning. Tools VNMT right hand corner radius 0.2 millimeter. Setup time 2 minutes and the runtime 81 seconds. For the last operation or fourth operation is part cut off. Machine is turning. Tools turning grooving, corner radius 0.8 mm and 10 mm diameter. And setup time 3 minutes. Runtime 49 seconds.
Thank you so much for my partners Syahidan and Zelynda that already explained about machining process. Next one, we need to determine the unit cost. Unit cost will be explained by me. Happy watching!
Well, after we had the machining process, we need to determine the unit cost for each product. We have the data right here, the dummy data, setup cost, fixture cost, NC program preparation cost, and the other costs that we can use this data for the calculation. Before that, we have the material is beryllium, and beryllium cost in marketplace is 120 per grams. And this is the formula for calculating the unit cost. We have material cost, we have plant cost, and the total of production cost. So we need to determine one by one. First of all is material cost. Material cost we got from addition, raw material cost with indirect cost. Indirect cost we assume it 200,000 because indirect cost will be a shipping cost or a service cost, so we assume it to 100,000. And for the raw material cost, we need to convert from millimeters cubic to grams. We have this data in the highlight, and then we convert to grams. So after the calculation, we got the material cost. Raw material cost is 41,000. So the material cost will be 241,000. Okay, next one, we need to determine production cost. Production costs have three components that we need to addition, setup and tool costs, add with machining costs, and add with cutter costs. First of all, we need to determine setup and tool costs, or CR. CR have three components too. Those are is setting costs, fixture costs, and CR cost. CR cost is NC cost. Okay. We already have the data and we just to add them all, and we got the result is 1,750,000. After that, we need to determine the machining cost. Machining costs come from the cost for each minute's machining and the time. But first of all, we need to calculate the time from the data. We got 27 minutes. After that, we calculate with the cost for each minute, and we got 40,624,5. And the last is we need to calculate the CC. CC is cutter cost. Cutter cost is from the tool cost for each minute and for tool life. So this is the formula, and we just calculated from the data, and we got 406,2, 4, and 5. So we need the production cost with at CR, CM, and CCR. We got production cost 1,791,031,745. And for the last, we need to calculate for C plane. C plane, we have C raw material or cost for raw material, and next for the CP. CP, that's mean production cost. So we just have 41, and we also have 1,791 about production cost. So the C plan, just add this 2 point, and we got 1,832,31,745. So the unit cost will be determined by 8 the material cost, plant cost, and the total production cost. So we had this calculation from the data above, and one unit product will cost about 3,864,063,49. So that's all. Thank you so much.
Thank you so much for everyone that already participate in this project, for my lecturer and my other friends in the class. Hope you guys will love this video. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.